Okay, today our lesson will be graphs of polynomial functions when they are in factored form. That means the polynomial is completely factored. So we just go directly to the graphs. The first thing we should see is we have to find the degree of this function here. The degree of this function here, I can see it here. Exponent here is 1 plus 1 plus 1. So the degree is 3. Therefore, I say the function is odd. Once I know the function is odd, the coefficients are the multiplication of all the coefficients. Coefficient of x here is 1 because there is no exponent here. 2 times 1 times 1 times 1, which is 2. So I say coefficient is positive. If the coefficient is positive, we know that the graph will extend always from quadrant 1 to quadrant 3. So we just say now what are the x-intercepts. The x-intercepts are whatever makes the bracket 0, 1, negative 2, and 3. Negative 2 and 3. Then it's easier always to find the y-intercept. Y-intercept is when x is 0, therefore 2 times negative 1 times 2 times negative 3 will be positive 12. Okay, so once I have these important points here, I just sketch the graph. So I know this is x, this is fx. I just plot the points. X-intercept is 1, and then 3, and then negative 2. They are not in scale, therefore I just write here 12. They're not drawn in scale, just rough sketching. So since I know it's odd and the coefficient is positive, so I start from here. X minus 3 is a linear, so it comes like a linear here. Then it comes down, we don't know exactly where because we have to use calculus to find this one here, to find the minimum. So it passes through here, x minus 1 is a linear, and then I go to 12, and then I go to x minus 2 is a linear 2, x plus 2, so it extends here. So this will be the graph. It's odd and the coefficient is positive. Okay, let's see B. If the coefficient was negative here, it would be exactly the same graph, but the other side around. If this was, let's say, if this was gx is equal to negative 2, x minus 1, x plus 2, x minus 3. The x-intercepts are the same. Since the coefficient is negative 2 times negative 1 times 1 times 1 times 1, coefficient is negative. Therefore, coefficient negative and odd, the graph always extends from quadrant 2 to quadrant 4. So the graph of this would be exactly the same, but the x-intercepts are the same, negative 2, 1, and 3, and negative 12. So it would come from here, then it would come to negative 12, then it goes to there, then it goes to here. This is the graph when coefficient is negative. Okay, so let's see other type of graphs here. Let's see, this is gx is equal to 3, x minus 1 square, and x plus 2 square. So the first thing we say is degree. Degree is, this is 2 plus 2 is 4. The degree is 4, therefore it's even. The coefficient is 3, 1 square is 1, 1 square is 1. So I square, make sure to understand the brackets and square So if the coefficient here was 1, it's 1 square. If this was 2, 2 square. So coefficient is positive. If the coefficient is positive and even, so we know that the graph will go from quadrant 2 to quadrant 1 to quadrant 2. Okay, so since let's see the same way, find the x-intercepts. Find the x-intercepts. X-intercepts are 1 and negative 2. Y-intercept. Y-intercept when x is 0, so negative 1 square times 2 square, 4 times 1, 3. Again, it's 12, coincidentally. So let's see, this is x and dx. They are 1 and negative 2. And this is positive 12. So since we know its degree is even and the coefficient is positive, it starts from here. At x minus 1, it's a square. A square means a parabola bounces back. So it comes like a parabola, bounces back from here because it's a double root. So it goes here, then it comes here. At minus 2 again, x plus 2 square. X plus 2 square is a parabola. So it bounces back. Okay, it bounces back because it's a parabola with double roots, x plus 2 square. If this was like gx equal to minus 3, x minus 1 square, x plus 2 square, the x-intercepts are the same, so the degree is even and coefficient is negative. If the degree is even, coefficient is negative, it is the other way around. It starts from here, it ends up here. It's upside down. Therefore, since the degree negative here, the y-intercept changes here. The y-intercept is negative 12. So negative 12 here, and here we have negative 2, and here we have 1. So exactly the same way. It comes from here, bounces back, then comes through to 12. At 1, it's x minus 1 squared, it bounces back. Okay, so this all here, it was easier because they were all factored form. Okay, we'll see the other ones when they are not factored.